Hello learners, I am Karesh Pundekar, Assistant Professor in Physics at Ganpat Parsigar College of Education. In today's physics course entitled Everyday Physics with Demonstration, we are going to learn a new topic, that is Physics of Circular Motion. So let us start. Now let us start with the topic Physics of Circular Motion. So what is circular motion? Circular motion is described as the movement of an object while rotating along a circular path. Best example you can understand with the example: if you tie something, a stone, with a string and you just try to rotate it, you will get a circular motion. Circular motion can be either uniform or non-uniform. So what is the difference between them? During uniform circular motion, the angular rate of rotation and speed will be constant, while during non-uniform motion, the rate of rotation keeps changing. So here you can see, in case of uniform circular motion, speed remains constant as we have seen. But in case of non-uniform circular motion, speed changes. But now what about velocity? In case of uniform circular motion, velocity also changes like in case of non-uniform circular motion. Because in case of uniform circular motion, though the speed remains constant, the direction changes at each and every point. That's why the velocity changes. If there is a change in velocity, that implies there will be an acceleration, and that acceleration leads to the force. Okay. In case of uniform circular motion, speed remains constant. In non-circular motion, speed changes. But what about velocity? In case of uniform circular motion, velocity changes as in case of non-uniform circular motion. Because if you see, in uniform circular motion, speed remains constant, but at each point the direction changes. That's why velocity also changes. If there is change in velocity, there will be acceleration, and that acceleration with respect to the circular motion will be called centripetal acceleration, which will be towards the center. As we have seen in the topic Newton's law, acceleration leads to the force equal to mass into acceleration, that is Newton's second law. So centripetal acceleration will lead to a centripetal force. In case of centripetal acceleration, it was towards the center. Same way, centripetal force will be towards the center. Now, what is centripetal force? Centripetal force is a net force towards the center. Example, string and a stone. As I have mentioned before, if you tie a string to a stone and try to rotate it, it will take a circular motion. But what is holding that stone? Here in this case, it is a tension on the string. Next example would be earth and the sun. Earth and the sun. Earth is around the sun. Now, what is holding earth towards the sun? That is gravitational force. In this case, here the centripetal force is gravitational force. Now, next example would be nucleus and electron. Electron revolves around the nucleus. So, what holds them together? That is centripetal force. In this case, it is a electrostatic force. We also have, along with the centripetal force, in case of circular motion, that is centrifugal force. So now, what is centrifugal force? Let's understand what is centrifugal force. It is a fake force or pseudo force. It is a centrifugal force, is a force that acts on object moving in a circular path. But the direction of the centrifugal force is apparent outwards when mass is rotated. Here you can see on the picture that the boy is holding a ball with the help of string, and it is taking a path of a circular motion. The centripetal force will be inward, whereas centrifugal force will experience a outward force. So ball is experiencing two forces, that is inward and outward. Inward is considered to be centripetal force and outward is centrifugal centrifugal force. Example, let's understand the centrifugal force with the example. Merry-go-round or giant wheel. You must have experienced when you sit in a giant wheel, you experience a force which is outward. Suppose I am observing you, you are on a giant wheel, I am observing you, and you are in the giant wheel which is moving in a the platform is taking a circular path. Then I can say that it is attached to the it is attached to one rod, that's why it is moving in a circular path. But when you are sitting inside that platform, in your frame of reference you are stationary kind of, but you experience an outward force. That force is nothing but a centrifugal force. So that's why it is called as a pseudo force. I can see it, but if you are in that frame of reference you cannot see it. Next would be car taking a turn. You must have experienced this. When car takes a turn or bus takes a turn, you feel a force which is outward. That is an example of centrifugal force. Water in a bucket. If you put a water in a bucket and try to rotate it with a force, when the if you have to rotate with a force such that bucket is on the top, but the water doesn't falls down, although there is a gravity. That is because gravity is encountered with the centrifugal force. So let's distinguish centrifugal force and centripetal force. Centripetal force, the force required to provide centripetal acceleration to a particle so that it moves in a circular path. Centrifugal force is the apparent outward force on a mass when it is rotated. Centripetal force, it is directed radially towards the center of the circular path, whereas in case of centrifugal force, it is directed radially away from the center of the circular path. Next point would be, in case of centripetal force, it is a force arising from gravitational or electromagnetic interaction, etc. In case of centrifugal force, it is a pseudo force since it is the effect of the acceleration of the reference frame of the revolving particle. So let us understand this with a demonstration, that is centripetal force and centrifugal force. Let us understand this centripetal force and centrifugal force with the help of demonstration. Now let us understand centripetal force and centrifugal force with the help of a demonstration. So we have seen centrifugal force arises for a circular motion. So best example to understand is that tying a stone to a string. Here in this case I have taken a bob. If I tie like this, and if I try to rotate that bob, it will perform a circular motion. So here in this case there are two forces acting, that is centripetal force and centrifugal force. So as we have seen, centripetal is directed inward and centrifugal force is directed outward. So let us. So what is holding this bob inward? That is centripetal force. Which force is there? What is holding which force? Because of the string, it is intact, means there is tension on the string. So now let us see where there is a centrifugal force. So to understand this, the centrifugal force, what I have done, I have tried two bobs and made sure it is attached to each other with the help of a body. That is a straw, or you can take a pen. Here you can see if I pull this is also getting pushed. So now let me rotate this bob. I am just holding the pen. When if I try to rotate, so this will perform a circular motion. Okay, there is a centripetal force which is holding that bob. So where there is a centrifugal force, you can see here centrifugal force should be outward. If you try to rotate, you can see other bob is moving upward. That means something is pulling that bob. That is this bob. Bob 1 is pulling the bob 2. Bob 1 is pulling because of the centrifugal force which is directed outwards. So here you can see with this demonstration, you can understand the centripetal force and centrifugal force. Thank you. So for more information you can refer these books. Thank you so much for your attention.